This demo is to present the Environmental Impact Optimizer module. This module comprises two tools, the Environmental Impact Monitoring tool and the Environmental Impact Estimator tool. We will start by presenting the first tool, the monitoring tool, that uses Grafana and Telegraph, and then we'll present the estimator tool, which is REST API. This REST API comprises two endpoints, the storage, the dataset storage energy profile and the data processing workflow energy profile. And later we will present the conducted experiments to estimate the data, to collect data for the estimator of the data processing workflow energy consumption. The monitoring tool helps to monitor any process power consumption. It uses a telegraph agent to collect metrics related to a process. The telegraph agent will be set to send collected data to an influx database, and the data will be proceeded and moved to specific buckets to be ready to be used by the Grafana dashboard. So the Grafana dashboard comprises two dashboards, one for the CPU usage power consumption and the second for the GPU usage power consumption. The GPU usage power consumption only works with NVIDIA GPUs. Okay, and also we are providing with this monitoring tool a user guide that explains how it works, and the core component of this monitoring tool from end user perspective. So we have details here, like the some explanation regarding Telegraph, how it works, what needs to be set, as well as Grafana, and we have also the steps to follow to initiate the monitoring of a specific process, or more specifically data processing workflows. Also, we provide some ideas on how to make the data processing workflow greener. Here I would like to demo how to use the Telegraph agent as well as the Grafana dashboard. So the first thing I would like to show is the Docker Compose file. Notice that we are here mapping the Telegraph config file as well as the PID txt file that will contain the data processing workflow PID. This file will be provided by Cedar as well as the Docker file and the Telegraph conf file. So if we take a look to the Telegraph conf file, here we are telling Telegraph agent that he needs to tag all the collected data with the following tags. So it needs to set the data processing workflow execution ID, to add also the location of the data processing workflow execution and the CPU model used for the execution. Also, we are telling the Telegraph agent to use these two plugins. The first one is to collect these two, so the Procstat and the InfluxDB v2. The first one is to collect the metrics related to the data processing workflow, and the second one is to output the collected data to an InfluxDB database using this token to connect and putting the collected data in a specific bucket called TMP. Okay. Now what we need to do is to to start the container. For that, we need to execute this command. All these commands are described in the user guide. And to check the log, we can see here that the tags are enabled and that the agent successfully connected to the InfluxDB database. So from here what we need to do is to execute the data processing workflow. So here, without putting the PID and the PID text file. Once it started to execute, what we have to do is to go to the Grafana dashboard. As we said, we have two Grafana dashboard, one for the CPU and the second one for the GPU. So we need to connect to the CPU ones to provide the data processing workflow execution ID, and here, and to wait until the data is collected. The first data is collected, proceeded in InfluxDB, and fetched from the Grafana and displayed in this dashboard. So let's check our script is still running. If you go back and refresh here the data. So let me check that we are using the right really graph. So here is the execution ID that we need to follow. Here it is, sorry. So it was a problem related to the identifier. So here we can see that we are following the power consumption in real time. We have also the energy in watt hour and in joule, and the equivalence in mile with this rule. So for the energy, it is the area under the blue line. So it's the blue area under the blue line, the power line, power consumption line. Also, we have in the this site the location of the data processing workflow execution with the cost in euro, and also we have the carbon emission and the carbon intensity. Here the estimator tool, as we can see, it's a REST API. This is the Swagger interface of the REST API that contains two endpoints: the dataset storage at idle energy estimator and the data processing workflow energy estimator. Once we are authorized, which means that we provide the login password, we can use this documentation to try the two endpoints. So here I will start with the first one to estimate the dataset storage energy consumption at idle. So what I need to click on the try it out button. So here I need to provide the metadata about the dataset, like the dataset size in gigabyte, as well the duration of the storage, and where I will be storing that dataset. When we execute this request, what will happen? We'll get back the stored dataset energy profile, as well as some optimization scenarios adapted to that case, what you provided. So here we can see that we have the energy consumption in watt hour. We have the carbon emission in CO2 gram. We have also the energy cost in euro. We have an information about the storage model efficiency that we are using, and the storage usage efficiency, and also some scenarios. So these scenarios can help to improve our power consumption and to reduce it, of course. The second endpoint here, to estimate the data processing workflow energy profile. We can also test this endpoint by clicking to the onto here in the try it out. By default, we have an example, so we'll here stick to that example. But let's see what we have to provide as an input. So what we have to provide is two main information. Is the workflow workload from one side, and the workflow execution environment from the other side. So for the workflow execution environment, as it suggests, so we need to provide information if we are using Docker containers, if we are what kind of CPU we are using, or process unit that we are using, specification, and where we are executing that data processing workflow. From the other side, we need to provide also the workload of that data processing workflow. So for that, we need to precise the data set size and the workflow specification. And the workflow specification is described by a list of what we call stages, and each stage has an identifier, a name, and a next step. So when we execute, we will get back the data processing workflow energy profile with the consumption in watt hour, the energy consumption in watt hour, the carbon emission in CO2 gram, the energy cost in euros, and the explainability related to these values, the energy consumption, and as well as some optimization scenarios, the same way as the first end point. Also need to precise here that you have the description of each input object here, so we can have the details here. This is more related to how the Swagger interface works. And if you go more specifically to the workflow specification, we have a list of items that has this structure. And if we go to the name, we can see all the possible stages that we can have for data processing workflow. Now we'll move to the presentation of the experiments that we executed to collect data to train the model that we have behind the second endpoint, the endpoint related to the data processing workflow energy consumption estimate. To train the power estimator model, we needed to collect power data via experiments. So first we needed to understand the server specification that we need to target for our experiments. For that, we collected data from SPEC. The SPEC organization is the Standard Performance Evaluation Corporation, and we analyzed the data collected from there. So the SPEC website provides the results of different benchmarks, and we analyzed the power benchmark results as it evaluates systems across multiple load levels and reports results in terms of operation per watt. So let me present for you an example. So an example of collected data from the SPEC website. So here the target load is the CPU usage, and we have also the power average data, and this is for a specific CPU models. So we collected all the available data there, and we analyzed the result, and we had the confirmation that the power consumption depends on the CPU models. Based on the result insights provided by the data analyzed from the SPEC power benchmark, we decided to use the Grid 5000 test bed for our experiment, to execute our experiments. This test bed provides around 1,000 nodes grouped into 30 clusters across 8 sites. So this is from one side. So also we tried to target on the Grid 5000 only unique CPU models. So we have identified 26 different CPU models that are useful for us. And what we are doing, we are executing the workflows per stage for different database sizes, and they are executed in different nodes or with different CPU models. Needed also to define how many runs we need to do to collect accurate power metrics. This is related to the nature of the power tools that are used. They can have accuracy issues. So for that, what we did, so we executed more than 500 operation in the same server and the same servers 10 times, and we analyzed the results. So as we can see here, we have the same shape, and this is due to the fact that in the grid 5000, when we reserve a node, we can install whatever we want and execute scripts, etc. But after we finish, grid 5000 reset the node to a stable state, and it is the same state each time. So also we still need to execute our experiments at least 3 times to detect experiments that fails, like like shown in this case. So we can see, based on the information that we have here, that run 1 and run 3 power data were collected correctly, while the one related to run 2, we have a shift of 50 watt. So this one will not be considered or valid data for us. To construct the experiment pipeline, we have a list of operation per stage, to which we are generating next flow scripts automatically. So each next flow scripts, it's an operation with the specific database size. So let me show you the scripts. We have several scripts, and for instance, in this example, I have the generator that will generate the different database sizes, and the different scripts operation, and the different next flow scripts. And the results will be stored in the scripts folder, inputs folder, and the generated workflows folder, that they are empty right now. So let's execute this command and answer the question accordingly. So here we can see that the different databases sizes are generated, and then the scripts were generated, and also we have the different data processing workflow, atomic data processing workflow generated. Why atomic? Because it's related to unique operation and apply it for a specific database size. And here we can see that the generated workflows are available now here, and we can open randomly one, and we have the details here for that operation. So this way we have very quickly per stage different workflows to be executed on grid 5000. As it was shown previously, our experiments can be reproduced easily, and we can generate further experiments with different database size if needed. So now I would like to demo how we execute experiments on grid 5000. So if you want, first of all, we check if the resource we have resource available on a specific site, like here I choose Luxembourg, and then we have to let me first of all show you. Here it is the repository where we will collect the results, and so in this node we have scripts developed that will execute the experiments for a stage automatically. So once we execute the script, it will what it will do, it will reserve a node on the Luxembourg site, as described in the script. Let us go back to here the resources. So we can see here, like now I have just reserved here a node for almost 4 hours. So and if I go back to my script to see what is going on, so we can see here that there are the specification are saved in this folder, and then the workflow execution started, and then here the completion ended with the status true, and then that we are collecting some metrics related to the power consumption, and that the metrics are saved in this folder and successfully, and that we can go directly to collect the data directly from the folder in the front end, or from this link. So if I open the link, you can see here that I have three kind of data. I have the spec data, and I have the collect data. It's the power data, power metrics, and I have the trace data. This is the trace data provided by Nextflow. So if I open this one, I can have the status of the execution of that operation. It is completed, and I have also some metrics related to the data, the CPU usage, and CPU usage, and RAM usage, etc. So also, if I go back here, sorry, if I go back to the previous screen, and I go to the collect power data, so and I can see here that I'm collecting data, like here BMC node power in watts, and it's 56 at this timestamp. So all this data is collected, and I can access. So here the script is continuing to execute the other workflow operation. So you can see that there are lots. So I will connect again to that site, which is Luxembourg. So here now I want to access the public results. So if I list, I have also the access to my collected result, and I can also like do some counting. Like here I have 6 traces operation already executed, and 5 so one executing right now, and we still didn't collect the power data for that 6th one, etc. So we have to wait until the end of the execution of the script. And also I wanted to show that here in the specification what we are collecting as data. So here some precision about the CPU of that node that we are using also to train our models.